Hello everyone, I am back with my new video of today's topic, some basic concepts of chemistry. Before starting it, let us recapitulate everything which we have discussed previously. We discussed about what was matter, anything that occupies space and has some volume and a shape is known as matter. What was volume, shape, etc. we have already discussed. Also we have discussed about what is pure element, what is impure element, what is pure matter, impure matter, element, compounds, etc. Okay. Then we discussed about impure matter, which is basically of two types, homogeneous mixture and heterogeneous mixture. Homogeneous mixtures are always solutions. Then we discussed about unit conversion from meter to centimeter, kilometer, decimeter, hectometer, millimeter, micrometer, etc. So I hope that all of these things are clear. Then we have discussed about normal temperature and pressure. Okay, what is normal temperature and pressure? It is 0 degree Celsius or 273 degree Kelvin and atmospheric pressure of 1 atm or 1 bar, actually we can say also. Then we discussed about standard temperature and pressure and also standard ambient temperature and pressure, which is now used for finding out solutions, or basically all the observations made are on standard ambient temperature and pressure. But we are going to discuss all the properties which are in STD or STP and NTP only. Okay. Then we discussed about atomic mass unit. It is basically unit of mass of one atom or nucleons, or basically protons and neutrons. One proton has 1 AMU of mass and one neutron has also 1 AMU. So we discussed that we discussed about Avogadro's number also. It is a constant value which is 6.02 into 10 to the power 23. Okay. Then we discussed average mass of 1 AMU is equal to 1/12 the mass of one carbon atom, which is 1/12 of 1.67 into 10 to the power minus 27 kg. Okay. Now today we are going to start the mole concept. Okay. So there is a formula, N into Na is equal to N. I know you have not got anything about it, so let me elaborate it. Number of moles into Avogadro's number gives us the actual number. Okay. Let us see the examples. This will help you to let it get clear. Okay. See, this is the formula. N into Na gives us N. Okay. Number of moles into Avogadro's number is equal to actual number. So N can be also written as number by Avogadro's number, which will give us number of moles. Let us see this question first. 0.2 mole, convert 0.2 mole into actual number. So we will directly put the formula. N into Na is equal to N. So here N is number of moles into Avogadro's number, which is constant, and the value is 6.02 into 10 to the power 23. So 0.2 into 6.02 into 10 to the power 23, which gives us 1.204 into 10 to the power 23. Let us see one more question here. Convert 1.806 into 10 to the power 25 into mole. So this is basically actual number. We have to convert this into mole. So we will apply this formula. N is equal to N by Na. Number of moles is equal to actual number by Avogadro's constant. See, N is equal to 1.806 into 10 to the power 25 by 6.02 into 10 to the power 23 mole. So this will give us 30 mole. Okay. Now let us see one more question here. Convert 1.505 into 10 to the power 24 into mole. So we will again apply this formula. N is equal to N by Na. So this will give us 1.505 into 10 to the power 24 divided by 6.02 into 10 to the power 23. This will give us 2.5 mole. Now another thing is atomicity. So I have already said you about atomicity. Atomicity is the number of atoms present in one formula of a substance. One formula can be an atom, an ion, a compound, anything, not necessarily to be a single atom only. Okay. See, atomicity of NH3 is 4. Basically it is asking number of atoms present in one ammonia atom, one ammonia compound. Okay. Similarly, atomicity of hydrogen in NH3. So hydrogen present in one ammonia is 3 atoms, so it is equal to 3. Similarly are the other examples. See, here is one more question. Which has the greatest atomicity? C6H5COOH or NH2CO NH2 or CH3COOH or C6H12O6. So basically we have to find the greatest number of atoms. So which option is having greatest number of atoms? So option 1 is having 15 atoms, option 2 is having 8, 3 is also having 8 and 4 is having 24. So 24 is the highest, so option D is the correct answer. Okay. Now see this question. We have to find the option which of the following does contain minimum number of atoms. Okay. 0.2 mole of He, 0.5 mole of C, 0.1 mole of Ne, 0.3 mole of Fe. So first we have to see whether all the given options has atoms or not. Okay. So He, C, Ne and Fe, all these fours are atoms. Now it is given in moles. So either we have to first convert it into number or we can directly compare it also. Okay, because mole is always Na and Na is a constant number. So we will directly multiply the given mole into Na to get the number of atoms. Okay, because small n into Na gives us the actual number. Simple. So 0.2 into Na, 0.5 and similarly like this it goes. So 0.1 is the smallest as compared to all this because Na is all common in all the 4 options. Okay, so it will have the least number of atoms. Now next question is which one of the following has maximum number of atoms. Okay, so here see 0.5 mole of He, 0.2 mole of H2, 0.1 mole of NH3 or 0.4 mole of CO2. See, first we have to see whether all the given options are in atoms or not. Helium, yes, it is an atom. H2, it is a molecule, so number of atoms in H2 is 2. NH3, it is a compound, so it has 4 atoms. See, 1 of nitrogen and 3 of hydrogen, so it will give us 4. CO2 has 3 atoms, 1 of carbon and 2 of oxygen, so atom will be 3. Now for finding which has the highest, we just multiply atom into the Avogadro's number, which will give us the actual number. Atom into mole into Na. Okay, so 1 into 5 into Na. Now there are 2 atoms, so 2 into 0.5 into Na, which is 1 Na. Now there are 4 atoms and 0.1 mole of 4 atoms. 4 into 0.1 into Na. Now 3 atoms and 0.4 mole, so 3 into 0.4 into Na. So 1.2, 0.4, 1 and 0.5, and Na is common in all these 4. So which one is the highest? It is 1.2. So it is 1.2 Na. Now this is some important formula. Okay, number of molecules into atomicity gives us the number of atoms. Okay, for example, let us see NH3. There is one molecule and there is how many? What is the atomicity? 3. So 1 into 3 gives us 3. So there are 3 atoms. Let us consider one more example. Suppose 3 molecules of carbon dioxide. So carbon dioxide has how many atoms? 3 atoms and 3 molecules of carbon dioxide. So 3 into 3 will give us 9. Okay, so number of molecules by Na is equal to number of atoms by N. We are dividing by Na in both the cases, so this will make no difference. So number of molecules by Na gives us number of moles, because actual number divided by Avogadro's gives us the number of moles. So N molecules, or basically number of moles of molecules into atomicity, gives us number of moles of atoms. Okay, where N is number of moles. This is the formula you must remember. This will make you to make your calculations even more faster. Okay, that's all for today. Thank you.